and g are two functions defined for all x is an element of R being the real number set by f of x equals 3x plus 2 and g of x equals x squared minus 1. Calculate g after f of 2. Express f squared x in terms of x. Determine if g after f of x is equal to g after g of x for all x is an element of the real number set. So g after f of 2. That means we do f of 2 first and then we apply the g function. So we're going to apply f of 2 first. So we're going to substitute 2 into our function f. So our function f of x is 3x plus 2. So f of 2 will be 3 multiplied by 2 plus 2. So we can keep the g stuck on in front to remind us that we then have to apply the g function. So we're subbing 2 into the f function, which is 3x plus 2. So we get 3 multiplied by 2 plus 2. 3 multiplied by 2 is 6, plus 2 is 8. So now we have to get g of 8. So we're going to sub 8 in place of the x in the g function. So g of x is x squared minus 1. So it becomes 8 squared minus 1, which gives us 63. So g after f of 2 is 63. So what we did was we substituted 2 into the f function first, and we end up getting 8, and then we subbed 8 into the g function second, and we end up getting 63. So part 2, express f squared x in terms of x. So what this means is we actually substitute our f function into our f function. So it becomes f of x. So we take our f of x function, which is 3x plus 2, and we're going to swap that x for 3x plus 2. So f of 3x plus 2 becomes 3 multiplied by 3x plus 2 plus 2. So what we did was we just swapped that x for 3x plus 2. So we're subbing f into itself. So 3 by 3x is 9x, 3 by 2 is 6, and 6 plus 2 is 8. So we substituted our f function into itself. Part 3, determine if g after f of x is equal to f after g of x for all elements of the real number set. So let's start off by working out g after f of x. So g after f of x, this means the g function is applied second and the f function is applied first. So since there's no number inside the brackets as there was over here, in this case we substituted 2 into the f function. But since we just have an x, we just literally write the function down again. So we have f of x inside these brackets, so we literally just write down our function, which is f of x, 3x plus 2. So I got that from up here, f of x equals 3x plus 2. Then I'm going to apply the g function. So my g function is x squared minus 1. So I'm swapping the x for 3x plus 2. So it's 3x plus 2 squared minus 1. 3x plus 2 squared will give me 9x squared plus 12x plus 4. So 3x plus 2 squared is 3x plus 2 times 3x plus 2, which gives us 9x squared plus 6x plus 6x plus 4, which gives us 9x squared plus 12x plus 4. So that's where that comes from there, and we just bring down the minus 1. Then we bring down the 9x squared, the plus 12x, and 4 minus 1 is 3. So now what we're going to do is figure out f after g of x, so the other way around, f after g of x, and the f function gets applied second, and the g function gets applied first. So we're going to have f of g of x, so we're literally just going to swap the g of x for x squared minus 1, because we don't have a number inside that bracket there to actually substitute into the function, so we just write down the g of x with brackets around it. And then we substitute x squared minus 1 into the f function, swapping the x for x squared minus 1. So instead of 3x plus 2, we get 3 multiplied by x squared minus 1 plus 2. And then 3 by x squared is 3x. 3 by minus 1 is minus 3, and minus 3 plus 2 is minus 1. So you get 3x squared minus 1. So for g after f of x, we got 9x squared plus 12x plus 3. And for f after g of x, we got 3x squared minus 1. And they are clearly not equal. Thus, in general, g after f of x is not equal to f after g of x. Although there are a couple of values of x for which these composite functions are equal. So sometimes it does work out, but usually the case is it will not be equal. So g after f of x is not equal to f after g of x.